What up, your boy C. Rizzy coming at you with Unit 4, Lesson 2, Triangle Congruence by SSS and SAS. Our essential question of the day, are there other ways that I can prove triangles are congruent? So last section we learned the only way to prove the triangles are congruent was by first proving that all of their corresponding angles were the same and all of their corresponding sides were the same, were congruent. So this SSS and SAS are other ways to do this. So our objective is to prove that two triangles are congruent using the SSS and the SAS postulates. You can prove that two triangles are congruent without having to show that all corresponding parts are congruent. In this lesson, you'll prove the triangles are congruent by using 1. 3 pairs of corresponding sides, or 2 pairs of corresponding sides, and 1 pair of corresponding angles. So again, as I said before you had to know which all the angles were congruent, all the sides were congruent, you had this congruency statement. However, this is more information about the corresponding parts than you need to know to prove that triangles are congruent. So let's get into the SSS, the side postulate, which says if 3 sides of one triangle are congruent to the 3 sides of another triangle, then the two triangles are congruent. So in this triangle, you see that AB is congruent to DE, BC to EF, and AC to DF. Therefore, triangle ABC is congruent to triangle DEF. Now, just like in the last section, these congruency statements are still important, okay? Because when you write the congruency statement, it also tells me which angles are congruent to each other. So I know angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. So once I've proven that these triangles are congruent, I can also prove that their angles are congruent. Okay, so sides is something very simple. Let's talk about something called sides and their included angle. So you can show relationships between a pair of corresponding sides and an included angle. So here's what an included angle looks like. Here they have angle A. Angle A is the included angle to sides BA and AC. So if I drew side BA and then I drew side AC, well, they create angle A. So A is the included angle to BA and AC. The other thing is you could have included sides. So over here I have angle B, over here I have angle C. Angle side BC is the included side to these two angles. Basically, it's in between the two angles, which makes it included. Same thing with this angle. It's in between the sides, so it's included. So, which gets us to the side angle side, the SAS postulate, which says if 2 sides and the included angle of one triangle are congruent to the 2 sides and the included angle of another triangle, then the two triangles are congruent. So here, AB is congruent to DE, AC is congruent to DF. Their included angles are angle A and angle D. So since that's true, I know that triangle ABC is congruent to DEF. Same thing still holds true. We have to write this congruency statement exactly as we see the triangles. A is congruent to D, B is congruent to E, C is congruent to F. So we write it in that specific order. Okay, so let's practice. Would you use side or side angle side to prove the triangles are congruent? So in A, you would use side angle side because you were given a pair of congruent sides here and here, and their included angle in here. So you would use side angle side to prove that these triangles are congruent. Okay, over here, you're given sides that were congruent to each other. In this triangle, you were given the included angle, but in this one, you weren't. This is the included angle here, and they told you this one over here was congruent. Therefore, there is not enough information to prove that these triangles are congruent. Letter C is simple. You have 3 sides that all are congruent to each other. Therefore, you'd use side. And in this one, you could use side, or I know these angles are congruent to each other by vertical angles, so I also have side angle side working for this one as well. Okay, so would you use side, 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 or side angle side to prove these triangles are congruent? So first off, can I use side, side, side? So side, side, side. Do I have three corresponding sides that are congruent to each other? Yes. So then the next question is, could I use side angle side? So here's my angles. So I have to look at the sides that include that angle. So this one I have the sides with 2 tick marks and 3 tick marks. And over here, the included sides are 2 tick marks and 1 tick mark. So those are not the same sides and the included angle. Therefore, no, you could not use side angle side for this one. Okay, what other information would you need to prove that triangle GHK is congruent to triangle KLG? Okay, so I already know that I have sides that are congruent to each other. I also know I have this side is congruent to itself by reflexive property. So what else could help me? Would knowing angle KHG, which is this angle, and GLK, so would that help me? Well, I've got the two sides and not an included angle, and they're not the included angle, therefore that's not going to help, so that one's out. HGK and LKG, would that help? Again, not the included angle, so that one doesn't help. Oops, let me get rid of those, so that one doesn't help. GHK, which is this one, and KLG, which is this one. Again, not the included angle, which doesn't help. So obviously, HKG, which is this angle, and LGK, which is that angle, that is the included angle to the two sides that are congruent to each other. Therefore, this would be my answer. Okay, would you use side, 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 or side angle side to prove these were congruent? So all I would need here is either the included angle, which would be these, or I need to know that's congruent to each other. So which one can I prove congruent? Well, I have no information about the relationship between those angles, so I have no idea if they're congruent. But this line I do know is congruent to itself by the reflexive property. So I can use side, side, side to prove the third side is congruent by the reflexive property of congruence, because it is, again, the same line shared by both triangles. All right, that's it for me.